Download this code from codegive.com, link in the description below. BitReader and OverflowException, a deep dive with detailed tutorial and code examples. The overflow exception in the context of a BitReader, assuming a custom implementation or one from a specific library, as .NET's built-in binary reader doesn't directly expose bit-level reading, typically arises when attempting to read a byte array that's too large to fit into the intended data type. This often happens when you're reading a number of bits that exceeds the capacity of the data type you're using to store the result, example trying to read 64 bits into a 32-bit integer. This tutorial will walk you through understanding this exception, its causes, and how to prevent and handle it, using illustrative C code examples. We'll assume a hypothetical BitReader class for demonstration. Adapt the principles and error handling strategies to your specific BitReader implementation. 1. Understanding the BitReader and the problem. A BitReader is a class designed to read data from a byte stream at the bit level, offering finer granularity than byte-by-byte reading. It's useful for handling data formats where bits are significant, such as compressed data or custom binary protocols. However, this increased precision introduces potential for errors if not handled carefully. The core issue leading to overflow exception is the mismatch between the number of bits being read and the storage capacity of the receiving variable. For instance, scenario 1 reading 33 bits into an int, 32 bits. The 33rd bit can't be accommodated, causing an overflow. Scenario 2 reading a large number of bits intended to represent an unsigned long 64 bits, into a long, 64 bits, that's treated as a signed integer. If the resulting value exceeds the maximum value of a signed long, overflow happens. Scenario 3 reading many bits to reconstruct a floating point number, where the bit pattern doesn't directly correspond to an integer. If the bit interpretation doesn't fit the floating point representation, it could lead to exceptions during the conversion, though not necessarily an overflow exception. 2. Hypothetical BitReader class, for demonstration. Let's define a simplified BitReader class to illustrate the concepts. This isn't a complete, production-ready implementation, but it suffices for our tutorial. 3. Code example demonstrating the overflow exception. In this example, attempting to read 33 bits into a 32-bit integer, int, will trigger the overflow exception. The uint version avoids the exception only because the number represented fits in the range of uint. But trying to cast it down to int after will throw the overflow exception again. 4. Preventing and handling the overflow exception. The best way to prevent overflow exception is to ensure that you're using data types that are large enough to hold the number of bits you're reading. However, this is not always possible or practical, especially in resource-constrained environments. Here's how you can handle it. Use larger data types. If you anticipate potentially large values, opt for long, ulong, or even big integer, for arbitrarily large numbers. The big integer class from the system.numerics namespace is ideal if you don't know the upper bound of the values. Check bit count before reading. Before calling read bits, calculate the number of bits needed and verify that it doesn't exceed the capacity of your target data type. Handle the exception. Use a try-catch block to gracefully handle the overflow exception. This might involve logging the error, using a fallback value, or taking other corrective actions. Improved code with exception handling. Remember to adapt these strategies to your specific BitReader implementation and the context of your application. Thorough error handling is crucial when working with bit-level operations to ensure the robustness of your code. Always document clearly the limitations on bit counts based on your data type choices.